Okay, today's lesson is talking about the properties of logs. But before we do that, I want to talk about the CUDA notes from class on Thursday. 8th period, I told this to them. 7th period, I did not. And those that didn't show up on the Zoom didn't get to hear it either. So first thing I'm going to do is scroll down to the bottom here and some notes about the CUDA worksheet. When you're doing logs with transformations and you're graphing them, you have to find the pivot point. Remember the pivot point. The pivot point is the point 1, 0. Hang on, we're going to see if I can get my iPad to work. Now it's working. Okay. The graph of a log function goes like this. Whoop, whoop, goes to that point right there, 1, 0. That's the pivot point. Okay. Well, I told you on this case that you would factor out the 2, and you'd have x minus 3 halves, and that it's going to shift that far. Well, this 2 has an effect on that pivot point. So the best way to remember that is first, this is called the argument. If you have the log base 3 of a equals x, a is the argument. Okay, so what's in parentheses? The argument. If you want to find the x value of the pivot point, you set the argument equal to 1. So in this case, it would be 2x minus 3 equals 1. You solve for x and you get 2. So my pivot point's at 2, and this is the vertical shift. It goes up 7. All right, if I want to find the asymptote, you set the argument greater than or equal to 0, just greater than 0. So 2x minus 3 greater than 0 gives me x is greater than 3 halves. So that's how you make your function, and that was how you get through that CUDA worksheet. Okay, it wasn't very explicit, and I didn't talk about it. This is something I just learned. I never really paid any attention to it. So that's something good. All right, for today's lesson, we're talking about the properties of logs. Log base b, if you rewrite this into exponential form, you'd have b to the x equals 1, and you go, oh, I know the answer to that. The exponent has to be 0. This, if I write it b to the x equals b, then x has to equal 1. All right, that's how I remember these things. Well, I guess I should leave that in there, but it's messy. Okay, anything log base b of b to the x is x. B raised to the log base b power is the x. This is, if your argument has an exponent on it, you can wrap it to the front and you get m times log base b of x. If you're multiplying two things, you can separate them. This is really important in calculus class. It's so fun. It's one of the only reasons I know to know this property. Okay, same with this one. In calculus, you use it when you're doing derivatives, and it makes your life a lot easier. So learn these and remember them when you get to calculus class next year. This is the change of base formula. You can do the log of n divided by the log of m, as long as these two things have the same base. So I could have done ln of n over ln of m. I could have done log base 3 of n, log base 3 of m. It don't matter. Pick one. Just be consistent. Okay? Those are the properties you expected to know those. And these two save your neck when you do derivatives in calculus class. Good stuff to know. All right, without a calculator, you rewrite this. This is log base 2 of 2 to the negative 1/2 power. That's an example of this one. So the answer is negative 1/2. Remember, this is log base 10 of 10 squared, and you took the 5th root of it. So it's raised to the 2/5 power, so that's 2/5. This one I had to think about for a minute. 0.2 is the same as 0.2 is equal to 2/10, which is equal to 1/5. So I have log base 5 of 1/5, which is the same as the log base 5 of 5 to the negative 1, and your answer is negative 1. Isn't that nifty? Peachy stuff. I like it when you can manipulate them and get answers. All right, this one I was like, what? What do they want me to do? Well, remember, a plus sign, this thing can go backwards. So this is the log base 6 of 9 times 4. which is the log base 6 of 36, which is log base 6 of 6 squared, which is 2. This is an exponent. You're subtracting. So you have log base 7 of 2 squared, which is 4 over 196. Well, 4 happens to go into 196, and you get 1 over 49, which is log base 7 of 7 to the negative 2, and your answer is negative 2. Those are fun. Didn't need a calculator. Smart, can handle it. Okay. Write the following expressions without logarithms. Well, this is log of A equals log of B, that's an exponent, times C squared. Since they both have a log, you can take 10 to the power and you end up with A is equal to BC squared. There's no logarithms in it anymore. We're done. Remember, this goes to the top. I have the log base 2 of A cubed. I move the 2 over here and move this over. Minus log base 2 of M equals 2. This is the log base 2 of A cubed over M. Then I change it into exponential form. 2 to the power 2 squared equals A cubed over M. And you're done. You can turn that into 4 if you want. Doesn't matter. Okay. Same thing here. I have ln of c minus ln of x squared equals 1. Remember, that's an exponent. That's ln of c divided by x squared equals 1. This is the same as log base e, so if I change it to exponential form, you have e to the first equals c over x squared. Here I have ln of k minus ln of s cubed equals negative h. ln of k divided by s cubed equals negative h. Change to exponential form, e to the negative h equals k over s cubed. Last three problems, they want you to solve for x, and exactly, answers that have an ln in them are perfect. Okay, first thing you do is divide by 3, because remember that 3 is separate. So you end up with e to the x over 2 equals 21 divided by 3 is 7. Now you take the natural log of both sides. And the ln of e to a power is just the power. Then you multiply by 2. And if you want, you can turn that into ln of 7 squared, which is 49. And that's your answer. Do not get your calculator out and give me a decimal out of your calculator. Don't want to see it. Okay? Remember, this is the same thing as log base e of e to the x over 2. And that's one of these properties up here. Okay? We don't need that, though. Okay. This one. Subtract 6 first. To the 2x minus 1 equals 23. This bothered me at first. I thought maybe we had a typo. But I think that's the whole point. Welcome to pre-cal class. They're not always pretty. Okay? And now it's like, well, what do I do? Well, if I take this log base 3 of 3 to the 2x minus 1 equals log base 3 of 23 over 7, this becomes 2x minus 1. And if you want, you can do this. You don't have to. All right? Now I'm going to add 1 to both sides and divide by 2, so you get the log base 3 of 23 minus log base 3 of 7 plus 1, because I add the 1, and now divide everything by 2, and you're done. Leave it that way. Don't get the calculator. I don't want to know it. All right? Unless it tells you. Okay? It wants it exact, so that's as exact. As soon as you put this in your calculator, it's going to give you a rounding. Okay? This one I separated. I have 8 to the x equals 5 times 4 to the x. I took the natural log of both sides. Why did I do that? Oh, because if you take the log of both sides times 4 to the x, this I can wrap that to it's an exponent, so I can run it to the front. This I'm going to rewrite into ln 5 plus x times ln 4, because an exponent could go to the front. Now put the terms with x on one side, so 8 x ln of 8 minus x ln of 4 equals ln of 5. Factor out the x. And now divide, so x is equal to ln of 5 over ln of 8 minus ln of 4. And you can stop there. Okay? One thing to keep in mind, go past my CUDA here, is if you have ln of 5 over ln of 4, that does not equal ln of 5 minus ln of 4. Okay? It has to be ln of 5 over 4. That has to be the argument. That does equal ln of 5 minus ln of 4. All right? Keep that in mind. Don't get tripped up on that one. That's all we had for today. Good luck. Bye-bye.